All right, hello. Today we'll be talking about interval notation and the musical alphabet. So I'm going to teach you how the musical alphabet works, why it works the way it works, and interval notation, why we use it, and then from here you'll learn how to analyze music, how to see those patterns, how to understand it better. This is super important. I think everyone should know this. I actually kind of wish it was taught in normal school, but my students definitely struggle with it, so it's worth talking about here. So let's start with a whiteboard like this. All right. The musical alphabet starts the same as the English alphabet. So we're going to go A, B, C, D, E, F, and then end on G. Music is pattern-based and it's cyclical, so it actually continues to repeat this to infinity. So after G comes A, then B, then C, then D, then E, right? And then below A, even on this side, right, is G. And this goes on forever. The only limitation is human hearing. This is not something that music really has to worry about. It just goes A, B, C, D, E, F, G, A, B, C, D, E, F, G, forever. So that's 7 notes total, right? 1, 2, 3, 4, 5, 6, 7. But there's actually 12 notes in music that we use. So these are called the natural notes. That's pretty easy to remember. Natural notes being the normal alphabet. But then you have accidentals, which are notes between these. So we have between A and B, A sharp. Between C and D, C sharp. Between D and E, D sharp. Between F and G, F sharp. And then between G and A, right? That's there. You have G sharp. So as you can see, the note above the natural note is the accidental. There's 2 outliers here, though. We have B and C and E and F. Those do not have accidentals. So how do we remember this? Well, 1, 2, 3, 4, 5, 6, 7 natural notes, and 1, 2, 3, 4, 5 accidentals. That's it. And then you just have to kind of remember which ones you're missing. You're missing B and C, and E and F are the 2. Okay. One level more complicated than this. If all you understand is this, that would actually be plenty. So don't even worry about the numbers at the bottom. Just this. The fact that the cycle goes on forever. You have A, B, C, D, E, F, G. And between most of these notes is a sharp, the exception being B and C and E and F. There is one step further, which is that every accidental actually has 2 names, a sharp name and a flat name. Flat meaning below and sharp meaning above. So A sharp is above A, B flat is below B, but those are actually the same note. So C sharp, all other name would be D flat. D sharp, other name would be E flat. F sharp, other name would be G flat. G sharp, other name would be A flat. Hopefully that makes sense. This doesn't need to be confusing, but it does have 2 names. The reason it has 2 names, there is actually a very good reason for that. We'll discuss why in a second. But that's all you need to know for now. Now let's talk about the foundations of making a scale using this, right? So in music, there's one kind of fundamental rule, which I love, which is that you're only allowed to have 1 of each letter. So accidentals, you can see that C and C sharp share the same letter, right? C. D and D flat share the same letter, D. So I'm only allowed to use 1 type of C, 1 type of D, but I have to use every single letter. So let's say I'm making an A scale. That could be any type of scale, but just an A scale. That would be this. That's an A scale, but what kind? It depends, right? So in this particular case, this sounds like that, which is an A minor scale. But if I wanted this to be a different type of scale, let's say A major, then I have this memorized. Don't worry about how I do this, but C sharp, F sharp, G sharp. Now, it's major. But if I do that, get rid of that sharp, now it's A mixolydian. If I do that, then now it is Lydian. So there's a lot of different scales. I could go through these all day, but hopefully what you see is that you modify this scale to get a bunch of different types of scales. And vast majority of scales are going to be 7 notes. All like normal scales are 7 notes, which is why the system kind of revolves around 7 as the concept of how many letters we use. All right. The most important scale to start with is actually the C major scale. C, D, E, F, G, A, B. The reason that's like the foundational most important scale on, especially on piano, is because it doesn't have any accidentals. So it, as a major scale, which is, we can think major as being like the most important scale. I think it actually is. So major scale, C major, no accidentals. So this is how you play the C major scale. If I wanted to modify this to minor, don't worry about how I do this, but just to re-explain that you use the same letters, just different modifiers, I do this. And now I have C minor, just like that. And you can see that I use flats this time instead of sharps, like last time. So why did I do that? Well, because I need E flat, that specific note. The other name for E flat is D sharp, but I needed D as well. And like my rule says, I can't have the same letter twice, and I can't skip letters. So D, D sharp, that's 2 Ds, and the next note after D sharp would be F. So I skipped E. Neither of those things can happen. This is just for the sake of simplicity, makes things way easier for us to predict scales, to analyze them, right? If I'm just keeping track of the letters, then all I have to memorize is the order of the alphabet, and then I can just figure out which modifiers I need to use for my accidentals. All right, so hopefully that makes sense. I'm now going to write the musical alphabet in a different way. Acknowledge that all sharps can be flats, all flats can be sharps, but I'm just going to write sharps so it's not as cluttered as it is up there. We have A sharp, B, C, C sharp, D, D sharp, E, F, right? No E sharp, F sharp, G, and then G sharp. Kind of running out of space there. Let me move this over. All right, perfect. So this is the order that I want us to look at it for interval notation. Now, interval notation is super powerful. The reason it works is that every single note in music is actually equivalent. So the name is kind of arbitrary. A sharp, B, C. The A sharp, 200, 2,000 years ago, whenever all of this was invented, it could have been called anything, right? So it could have been called C, could have been called B, but we call it A sharp. And that's for a certain frequency that we've labeled this. But it's all arbitrary. The thing that matters is actually the distance between notes, which is the intervals. Let's say that is root, the starting pitch, we'll call it root. The next pitch, we're going to call minor second. The next pitch, we're going to call major second. The next pitch, we're going to call minor third. Next pitch, major third. Next, perfect fourth. Next, tritone, or sharp 4. Next one, perfect fifth. Next, minor 6. Major 6. Minor 7. Major 7. So what did I do here and why? I removed the letters because they're arbitrary, and I said all that matters is the distances, because here's an example of that. I'm going to play the same progression in 2 different keys, and you're going to see they sound the same. It's just a different key. So we have that progression, which is C, F, G, C. But now if I change keys, fundamentally it was the same thing, right? If I made a song, sure if I made that in C. It'd be the same song, just a different key. So that's all I'm trying to get across here. So all that matters is these intervals. So now we have a name for each note. But the thing is, and what's going to make this very strange, is that we can move this scale. The difference between interval notation and actual notes is that this can move, this bottom note. So now, let's say I highlight that. What I can do is shift this wherever I want. And so now you can see wherever I shift it to, that becomes, my new root, my new minor second, my new major second, my new minor third, and so on. And so that's what makes this scale so powerful. What I'm going to do now is create a formula for the major scale, again, the most popular scale, and we're going to do it on C. So the C major scale, we said is C, D, E, F, G, A, B. In the notes here, I'm going to fulfill what is between these notes. So we have this, G sharp, and then A sharp. Okay, so those are the notes between. This adds up to 12. It should at least. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. So that's all 12 notes. We're only using the bottom ones to make the major scale. But C, being our starting note, is called the root. C sharp is called the minor second. D is the major second. D sharp now, minor third. E, major third. Then F is going to be the perfect fourth. F sharp is the sharp 4, tritone. G is the perfect fifth. G sharp is the minor 6. A is the major 6. A sharp is the minor 6. Minor 7. There we go. And then B is the major 7. So what formula do we get out of all of the whole notes? The bottom set here. Root, major second, major third, perfect fourth, perfect fifth, major 6, major 7, and then you're back to 1. So just to remind you how I got that, I had the C major scale, which I know, and I've told you, is the only scale where there's no accidentals to make it a major scale. So C major scale, C, D, E, F, G, A, B. Cool. So now what I did is I turned that into interval notation so I could learn what a major scale fundamentally is. What are the distances that make up a major scale? And I found that you get root, major second, major third, perfect fourth, perfect fifth, major 6, major 7. In other words, every interval is major in order to get a major scale. We'll continue with this concept, but this is a lot to look at, right? Like, that's very confusing. There is a way to simplify it in writing. Not necessarily simplify it in concept, but simplify it in writing to make it just less symbols to look at. So now we have the major scale formula, and hypothetically, I could put this on any scale that I want. So let's say I'm doing like the A major scale, for example. So then I write the musical alphabet starting from A. So I'll go like A, B, C, D, E, F, G. And then obviously all the sharps, A sharp, C sharp, D sharp, F sharp, and G sharp. And then I write out the notes, all interval notation, and I get root. This is minor 2. This is major 2. This is minor 3. This is major 3. Perfect fourth. Sharp 4. Oops, sorry. And then this is perfect fifth. Then this is minor 6. This is major 6. Minor 7. And major 7. All right. So again, hard to track, but I'm going to try to help you see what I did here. So root, I need. What else do I need? I need the major second, which is B. Cool. I need the major third, which is C sharp. I need the perfect fourth, which is D. I need the perfect fifth, which is E. Major six, which is F sharp. Major seven, which is G sharp. Let's go back here also just to teach you how these symbols work. So minor is this, and major is that. Just so you see that. So lowercase m for minor, uppercase M for major, but lowercase m looks a lot like uppercase M, so we just put a line over it to indicate minor. The way the interval notation works, back up here, let's try to find a simpler, okay, so right here. Interval notation, it goes minor, which means small, right? And then major, which means big, right? So we have small 2, then big 2, small 3, then big 3. And then we have 4 and 5, which are kind of strange. They're perfect, right? We'll talk about that. But then we have, again, small 6, big 6, small 7, big 7. So keep that in mind. That's how the system works. Small, big, small, big, small 2, big 2, small 3, big 3, and so on. And this makes sense, right? Because a small 2, this distance is pretty short, right? That line, pretty short. Big 2, that's a slightly bigger, right? So that's how you can also remember this. Smaller means like less space between those two notes. A and A sharp, and A and B. Different types of 2. And then same thing goes for minor 3, major 3, and then we have perfect. So now let's discuss how that works. Your root sounds like this. A minor 2 sounds like this. Major 2 sounds like this. Minor 3. Major 3. Perfect fourth. Sharp 4. Perfect fifth. Minor 6. Major 6. Minor 7. And then major 7. And then we're back at the octave, so same note on the top there. All right, so now we've heard every interval. We don't know why they're called perfect, right? And I do kind of wish that was more consistent, but short form, they're just really stable intervals. So if I play the root, which is also called like perfect 1 or perfect 8, it's just very stable. If I play 2 of those things, very stable. That's the octave. So if I play a perfect fourth, also really stable and really beautiful. If I play a perfect fifth, also stable and really beautiful. But the rest of them, a little bit less stable, right? A little bit less, maybe a little bit, definitely unstable. Super stable. So I'm not the one who made up these words. I wouldn't say perfect as a method of stability or mathematical stability, but just understand that's how the system works, and unfortunately we just have to memorize it, and it will become very useful in the long run. Okay, so I just taught you how to make a major scale, right, using this. A, B, C sharp, D, E, F sharp, G sharp. That is how you make a major scale. For A, we found those modifiers by knowing what the major scale formula was and then applying it to these notes. So let's take this and simplify it a little bit. If the major scale formula is 1, major 2, major 3, perfect fourth, perfect fifth, major 6, major 7, and the major scale is the most important scale of all, then why don't I just make this the default? So this is what the Berklee College of Music method of learning this stuff is. You don't use major and minor anymore because it's just too many symbols. So to simplify it, we'll just go 1, 2, 3, 4, 5, 6, 7. This still means exactly what this means. We're just now simplifying the writing. And if we have a minor interval, for example, minor 2, then I'm going to say flat 2. If we have a minor 3, flat 3. 4 and 5 can't be minor. They're always perfect. there's a sharp 4. So if there was a sharp 4, I would do that. But sharp 4 is also known as flat 5. I would do that. But those can't be minor or major. So then we have minor 6 versus major 6. If it's minor, flat 6. If it's minor 7, flat 7. Does that make sense? None of this is intuitive at first, I wouldn't say. If you're getting this immediately, I would be very impressed. This takes a while for people to get. So if all you got from this video was the musical alphabet at the beginning, just the knowledge of the order of the notes, that's good with me. I'm going to re-explain that on the piano in a second, but this is where we're starting, and this will be really good. All right, next thing to acknowledge, let's learn the minor scale. We learned the major scale, most common scale. Now let's learn the minor scale. The minor scale formula comes from, let's say, take a key that with no accidentals is minor, so A, right? So I already did this, but let's rewrite it. A, B, C, D, E, F, G. Now I'm telling you that this order of notes, this interval distance, is the minor scale. So now you're going to use the intervallic notation to understand what this formula actually is, so you can apply it to other keys, not just A. So let's find this. The first one is going to be the root. Between A and B is A sharp. Between C and D is C sharp. Between D and E, D sharp. Between F and G, F sharp. Between G and A, G sharp. Okay, so that's all the notes that exist in music. We know that the bottom layer here is the minor scale. So over here, this middle section, let's change color, is the minor 2. And then after minor 2 comes major 2. Then the next one after major 2 is minor 3. Then major 3. Perfect fourth. I wrote this too small. One sec. Minor 3. There we go. Perfect fourth. Above perfect fourth is sharp 4 or tritone or flat 5. Then E is perfect fifth. Above perfect fifth is minor 6. So this is minor 6. Above that is major 6. Then minor 7. Then comes major 7. All right. So now we take the bottom row of what we have here, and we rewrite that, and we get root, major 2, minor 3, perfect fourth, perfect fifth, minor 6, minor 7, and yeah, that was major 7. I should have written this up top, so that's not part of this. And then that's it. You only have one of each number, just like you only have one of each letter. Perfect. Now, if I turn this into the Berkeley method, or the way that I like to do it now, it would be 1, 2, flat 3, 4, 5, flat 6, flat 7. And that is your minor scale formula. Minor scale sounds like this. And now we're going to pick a super random key, and we're going to make a minor scale from that, so you can use this formula practically. So let's take a crazy key, like we'll do D flat minor, for example. So D flat minor, let's write out all the notes. We're going to go D flat. After D flat comes E. Oops, sorry, D flat comes D, then E flat, then F, then, oh my gosh, I'm so sorry. I'm getting locked out of this. D flat to D, E flat to E, then F, then G flat, then G, then A flat, then A, then B flat, then B, then C, and then D flat. All right, again, just a quick reminder, E and F, no accidental, B and C, no accidental. But that's it. Everything else had a note in between. We were using sharps before, now we're using flats. You're only ever going to use one. You're either going to use flats or you're going to use sharps. So we're going to go back here, and I'm going to give each of these an intervallic name. So root, minor 2. After minor 2 comes major 2, then minor 3, then major 3, then perfect 4th, sharp 4, perfect 5th, minor 6, major 6, minor 7, major 7, and then this is D flat, which was where we started, which is just the root again. So that actually doesn't matter. Okay, so now let's figure out which ones we're going to need to make a minor scale. We can use either of the formulas that I have up top here. We'll use the normal one, not the Berkeley method, first. And we see root, so I'll circle these. We need the root, which is here. We need the major second, which is this one. We need the minor third, this one. The perfect 4th, right here. Perfect 5th, here. Minor 6, there. Minor 7, there. And then that's it. So now I'm going to rewrite this again just so it's easier to read. D flat, E flat, then E, oof, that violates a rule. Then G flat, then A flat, A, that violates a rule, then B. All right, so what does this tell me? It tells me that D flat minor is not really a key that we'll be using. It's probably going to be C sharp minor. But let's take a look at this. So this, I said it violates some rules, right? It violates some rules because after letter E should be F, and there's 2 E's. So that's a problem. I can't have that. And then A flat to A, that also violates some rules. Again, now I don't have, am I missing any other letters? I must be. I'm missing C. So I need a type of C, and only one A, only one E. I need an F. All of those things. So technically, if I were to play this on piano, it would sound totally fine. It doesn't fulfill the intellectual goals of a scale, being easy to understand and easy to memorize. So this is what this is. That's a D flat minor scale, so that works. But D flat minor is clearly not a key that I'm going to be able to think in as easily. There must be a better method. So let's turn all of these into sharps, and let's see if the rule is still violated or if we're okay. We should be okay, just a spoiler. So flop this. D flat is the same as C sharp. E flat is the same as D sharp. E is just E. G flat is the same as F sharp. A flat is the same as G sharp. Then A, keep that. B, keep that. All right, so now are our rules fixed? C, D, E, F, G, A, B. Yep, that is now the order that we would expect. That's the musical alphabet. That is the normal alphabet. We only have one of each letter, and we're solid. So this means that if you were to write a piece using the key D flat, it would actually be less correct, music theory-wise, for the sake of confusion, right? Exact same thing. D flat minor is actually going to be better written as C sharp minor. I didn't actually think about that too much before I chose that example, but it's actually really good because it teaches you when there's a key that's a little bit too far. If we talk about perfect fifths on this channel, and I'm not sure if I will, if it's useful to people, I will, but then you'll start to see the circle of fifths and where this stuff comes into play. But all you needed to know from this lesson was the musical alphabet, A, B, C, D, E, F, G. Well, actually, yeah, we can look at it again. So musical alphabet, simple as this. Accidentals have two names, right? Sharp name and a flat name. Exceptions being B and C, no accidental, and E and F, no accidental. And then we learn the interval notation, which is when you take the system of 12 notes and just give them 12 numbers. Again, we don't have numbers actually 1 through 12. We do numbers 1 through 7 because scales are 7 notes. So functionally, it's more useful to have 7 numbers and then just have those qualifiers of those numbers, these variations. Then we use scales that I know exist and I told you exist. C major, no accidentals. A minor, no accidentals. So we took C major, looked at the intervallic notation of it to find out the chord formula or the scale formula. We wrote it down as root, major second, major third, perfect fourth, perfect fifth, major six, major seven, Berkeley shortened, 1, 2, 3, 4, 5, 6, 7. I like that. Makes it easier. And then we did the same thing for another key, and we took that formula, applied it to a different set of notes, and got the A major scale from that. Then we looked at minor. I said A minor was A, B, C, D, E, F, G. And then we looked at the formula of what that must be then if A is the root. And we found root, major second, minor third, perfect fourth, perfect fifth, minor sixth, minor seven. And then we took that formula and applied it to yet another key. And we did D flat, found the set of notes. The notes were correct. They work, but it violates a clarity law. It's like bad grammar, basically. I understand what you're trying to say, but the grammar of it is not optimal. It's not the one that we usually use. So then we flipped it to make it sharps instead of flats. You'll only ever have one, and now it makes more sense. C, D, E, F, G, A, B with accidentals as their modifiers to make this minor. I hope this video helped. I know this is a confusing topic, and a hyper-edited video might make this easier to understand, so I hope that there are other videos out there. But if this is helpful at all to anybody, that's what this is for. This channel is anyways just to let me talk about things that my students have problems with or that I used to have problems with, and for me to just share what's going on with what I'm thinking about. So let me know if there's any questions you want me to answer. I'm happy to do that. I love music theory. I think it's really cool. It allows you to hear a song on the radio and just play it instantly, which is like magic. It feels like magic to do that. And it's just from understanding patterns. All right, well, have a great rest of your day, and I'll see you later.